Yeah, hi everyone. I'm Will MacAlpine from Rothamsted Research. My expertise is plant breeding. I've been breeding short rotation coppice willows for about the last 20 years. But I'm hopefully going to give a more general talk about experiences with SRC willow. So Will just introduced the net zero piece. Why is this? How does this crop fit in? This is an ancient thing, coppicing, and this is the kind of planting cycle. I brought along some cuttings today that I'll pass around. This is how we plant them, a 20 centimetre cutting. The trick is get them the right way up. If pass them round, buds point upwards, this is where the shoots come up, and you'll see some corky light brown little dots on it. These are the lenticels, and these are where the roots come out of. So do have a look at them, and bear in mind, when we're looking at the field trial that we're going to this afternoon, it was all planted by those. So they're winter dormant woody cuttings, and that's where it kind of all starts. So we plant them in the spring. It's a spring planted crop. You don't get that much yield in the first year. It's one or two stems. Then the normal thing is to do coppice it. That's not an economic yield. There isn't that much biomass there, but it stimulates the multi-stemmed regrowth because you've lost apical dominance, and then it's a 3-year cycle. So you go round and round, and it's viable for up to and over 20 years from planting. But if you have first year cutback, you do have that initial pause, so it's 4 years till harvest, then harvest every 2 years. But there's flexibility with this crop. It can be harvested between 2 and 4 years. And then of course, after it's harvested, CO2 might be released on combustion, but it's absorbed through photosynthesis. So it's neutral as long as you don't truck the wood chip too far. And then it's got potential to add to negative emissions if it's paired with things like carbon capture and storage. But that's why we're interested in the crop. And crucially, it's not replanted, you're not having cultivation between regrowth. So I'm going to be talking about varieties, but I want you to look at varieties as the kind of cherry on the top of the cake. You need to get your foundations right before you get the benefits from good varieties. So I've made the circle for agronomy and best practice much bigger. The absolute key to these crops is forward planning in the season before, in the 6 months before. If you can manage a weed-free site, and a lot of your success is actually before you plant it. Now, I'm not going to talk about that today, but Kevin Lindegaard, who's talking next, did this excellent Biomass Connect webinar, webinar 1. Look on the website, look at that. They cover off land preparation for willows and miscanthus really well, and I just can't emphasise how important that stage is. If you get it wrong, you can lose between 50 and 90% of yield. So it's massive. Then varieties, like I said, it's the cherry on the top of the cake, but people like me put a lot of energy into breeding them so that they yield optimally. Having said that, I think rather than, you've got to start planning at the beginning. I think if you're considering growing this crop, you should really consider your end use market first, and then work backwards from there, because the specifications of your wood chip, the chip size, the moisture content, how you're going to use it, how you're going to harvest it, if there's a harvester nearby, are you going to do it yourself? You need to cover all of that off, and then that can influence how you design your plantation. And different harvesting techniques have different benefits. For example, this whole stem harvester, it's basically a trailer with a circular saw blade offset. You cut the whole stems, and then you can season the wood stacked up here or in bales, brash bales here. You can season it, and it gets down to a very low moisture content really quickly, but you have got a double handling because you need to move the whole stems away from the field. Whereas the forage harvester, the direct cut and chip, is very good, but you've got chip with quite a high moisture content. So if you're considering growing this crop, do consider how you're going to use it. Look at your boiler spec, look at who you're supplying it to, and consider that and work it that way. And I'd also say, I've drawn some little dotted lines. The consistency of cut height through your new plantation is really, really important. So if you think one year that you're going to hand cut it and you cut it a little bit high, that might actually block you from getting a forage harvester the next year. So you can see here the cut height is sort of quite consistent. The forage harvesters cut at around 10 centimetres, give you quite a straight cut. But if you hand cut it higher than that, and then the coppice kind of point where all the stems come from are a little bit higher than where the harvester would cut, you can get blockages and you can have problems. So this is why I'm talking about planning backwards from how you're going to harvest it. So they're hopefully some practical tips. And it's been wonderful, Biomass Connect. This project has helped harvest 2 sites this winter. Here at Aberystwyth, the site that we're going to look at, and also another site at Easton College in the east of England, very close to Norwich. And we've got 3 varieties in common between those 2 sites. And I just wanted to show the yields that the IBERS team cut here and also was cut a few weeks ago, so they're quite comparable. We've got 4 varieties, endurance and resolution. Actually, Kevin Lindegaard, who's here, bred back in the day, are doing really, really well, and you can see these are slightly lower yields. I wanted to explain the unit that we're looking at here. I've got tonnes per hectare per year, and it's dry weight as well. So whilst those look, let's do 10 so we can do the maths quite easily. 10 oven-dried tonnes per hectare. Actually, it's around 50% moisture content. It's actually between 45% dry matter and maybe 55% dry matter. It's the kind of variation. So let's call it 50%. So that's actually 20 tonnes of wood. And then you times that by 3, because it's a 3-year cycle. So you're actually talking 60 tonnes from the field. So I've divided these by 3 and it's dry matter. So just when you see those kind of lower things, I'm talking oven-dried tonnes per hectare per year. So yeah, you can see that whilst there is a little bit of variation, the 2 good varieties, endurance and resolution, are doing particularly well at both sites. But actually, looking at the site here and the site at Easton, it's maybe a little bit sporadic and it gives good independent data, but we want to look at it and give better data to growers. So one project that I'm working on that's funded by the same Department of Energy Security and Net Zero initiative, we've been looking at accelerating willow breeding and deployment, and we're really keen to, at every point, release information that will help the growers. So rather than save it all up to the end, kind of incrementally release data so that growers have it, can make decisions. It's a viable crop right now, but I think we're going to get more and better data from it that will help it be deployed with more impact. So what I'm going to talk about now are trials planted between 1997 and 96, and a large multi-site statistical analysis where we can look at it all in the round rather than just at 1s and 2 sites. And the sites that we're talking about are from the black blobs on the map and the blue blobs on the map. But you can see this year we're going to be planting new experiments at the blue sites and the red sites that are going to give us better coverage. So whilst the data that we've got now is good for these sites, we can always have better coverage. We looked at biomass yield, and we also looked at dry matter content, and also the weather effects on these crops. So I'm based at Rothamsted Research in Hertfordshire, and we hold the Willow collection, which is a unique Salix willow germplasm resource. We've got 1,500 different types of willow. This is an aerial shot of the willow collection. You can see the diversity in leaf morphology and colours and so on, and it's a wonderful thing to work with. And this is the basis of our breeding germplasm, so to make crosses to get better varieties. And this funding has allowed us to extract DNA from all of those willows, 1,500 different types, and sequence them. And before we relied on taxonomic keys and so on, but this has given us hard genetic quantitative data to produce a dendrogram like this to really understand the relationship in salix. So there are around 450 different species of salix, and seeing how the pure species, the hybrids, and the varieties all interact has been really, really beneficial. A lot of these actually are small species, some Arctic shrubs that you wouldn't want to grow for biomass, or tree species that don't respond to coppicing that well. So there's actually a narrower diversity group that are short rotation coppice willow varieties. But I wanted to share with you this amazing resource that we've got together. Now this is really what growers would be interested in. These are the numbers of near market or current varieties that you could grow as a farmer or a land manager now. And so far, we've been really recommending that people plant a 6-way mix. So the harvest window is when the leaves have fallen off through the winter. You don't have to worry about harvest uniformity, like some combinable crops and so on. And also it's a 7-metre tall crop. You can't drive a sprayer through to spray with fungicide or anything like that. So we really want to plant it, and from an energy point of view and a practical point of view, we don't want to be putting inputs on. But we also don't want pest and disease resistance to break down. So the really important thing is to plant, we recommend a 6-way mixture. And the knowledge of experts has been able to kind of guide that planting, but this has allowed us to really dissect the diversity. So rather than saying planting 6 willows and accidentally ending up with 6 that are there, and you actually have got quite a close genetic relationship, we can say, well, actually, you want to plant one from that group, and then one from this subgroup, one from this subgroup, one from this subgroup, and one from the others, and then you've got a genuinely diverse genetic resource. And that, making that decision ahead of planting, will give you a kind of insurance policy to make sure that rust resistance and so on doesn't break down. We've got great rust resistance at the moment, and the breeders have put a lot of effort into ensuring it's there, but the fear is that these break down and there'll be less disease pressure if we have this mixture. So if you look at plantations now and go, what's the problem? It's not a worry, but it's these rust pustules, Melanpsauria, willow leaf rust, that is one of the main problems, and it can cause early defoliation. The leaves aren't on, the plant's not capturing the sun's energy and photosynthesizing, and yields are reduced, and ultimately it can lead to early plantation failure as well if it happens. So you really want, investing in planting these perennial energy crop plantations, you want them to last. So a key message is go with a 6-way mix and make sure that you plant a diverse mixture. But you don't just want a diverse mixture, you want to ensure that you're yielding well. So this multi-site analysis looked at all these different harvest events, and really you want to be choosing genotypes that are operating up here. We hope that with future breeding the line will continue to grow up, but this is where we are right now, and this is why we want to share this kind of information today so you can get the optimal varieties. And when we crunched all the numbers, this is the list that we came up with. And I've tried to colour the different diversity groups to make it easy to choose from. So you've got 1, 2, 3, and then the 3s are split into A, B, and C. So there's a Viminalis and Scherinii hybrid, which is very common and produces brilliant biomass, but they're all quite closely related. And so whilst A, B, and C of group 3 are actually quite closely related, by picking from those subgroups, you're ensuring that you're getting the diversity within that. And they do come from different suppliers, and different contractors have different access, but we hope this is going to make it easier to see your way through planting. And I would say, whilst that's a kind of ranked table on yield, you shouldn't be too worried the difference between a decimal place is very major. A lot of those ones that are above 10, they're going to do you really well. But we hope with the future planting, we're going to get greater resolution and be able to make more precise recommendations. But if you're looking to plant this year or next year, it's think about the genetic diversity and look at these yields. We've also included sex, the gender of the genotypes. Some people really value having a mixture. You could accidentally pick females, and so you'd have no pollen provided by the crop. So willows are dioecious, they produce catkins, and catkins are either male or female. So by looking at this, you can choose other factors such as the sex and genotype. But there isn't an XY 50-50 sex relationship in salix. There tends to be a bit of a female bias, so there's more females there, but it allows you to choose one or two males if you so wish. And yeah, just to highlight, we've got a hub site here at Aberystwyth. My colleague Ben and I were marking it out this morning. Will just highlighted all of the species that are going in. This will, as I've talked about willows, it has got the potential to help you choose which other woody species or perennial energy grasses that you might like to plant. So don't think this is all about willow, there's other options that you could go with. But this is a site that has both miscanthus and willow variety trials on it. So we're going to be getting more and more information that's going to be passed on, which I'm really excited about. And yeah, I think that's the end. I've got 5 minutes probably if there's any questions, and also there's a chance to talk informally in the field as well once we have that tour.
Got one question for you on planting and establishment.